In this question, matrix A is given of order 2 cross 2 and A power 4 have some elements. In that, A11 entry value is 109 and we need to find the element at A22. So to find A power 4, first we need to find A square. Just multiply A elements. Matrix multiplication is possible and we'll get x square plus 1 x1. To get A power 4, multiply A square into A square. Now you'll get x square plus 1 whole square plus x square. And here these entries are not required, so it's better to leave like that. And here it becomes x square plus 1. Now equate the A11 entries, that is x square plus 1 whole square plus x square is, it's given as 109. So from here when you simplify, you will get it as x power 4 plus 3x square minus 108 is 0. You'll get two factors, those are x square plus 12 and x square minus 9. Square can't be negative, so x square is nothing but 9 over here. So to get A22 entry, that is x square plus 1, put 9 over here and you will get 10. So 10 is the required answer for this question. In this question, matrix A is given and B is also given. We need to find the value of A power 8 in terms of B. So how to do this? If you observe the question clearly, A matrix can be written as iota into B. So when you take iota common from the A matrix, the leftover part is nothing but the B matrix. So when you square it on both sides, it becomes A square equal to I square into B. I is nothing but root over minus 1. So I square is nothing but it's minus B. Sorry, minus B square. Now let us first calculate B square. That is 1 minus 1 minus 1 1 into the same thing 1 minus 1 minus 1 1. So when you multiply it, you will get it as 1 plus 1 2 minus 1 minus 1 minus 2 and 2 over here. Take 2 common. The leftover part is nothing but again the B matrix. So B square is nothing but 2B. From here we can write it as A square is minus 2B. So A power 4 becomes A square whole square, which is nothing but minus 2B ka whole square, which is 4B square. Again, B square is nothing but 2B, right? So 8B. Now A power 8 is A power 4 ka whole square, which is 8B whole square, 64B square. Again, B square is nothing but 2B. 64 into 2B, that is 128B. So option B is the required answer to this question. In this question, matrix A is given. We need to find the number of B matrices with the entries from this set, and this also satisfy the condition AB equal to B. So before that, let's assume B matrix as ABC, DEF, and GHI of order 3 cross 3. Let's use the condition given, which is nothing but AB is equal to DA. So now just multiply and equate. You will get it as, so when you multiply the first row with the first column, here it's like D is equal to, when you multiply with this, it becomes B. This is one condition. And next, it's E is equal to A and F is equal to C. G is equal to H So now just substitute these elements and write the matrix B. A will be A itself, B will be B itself, C will be C. D is nothing but B over here, E is nothing but A, F is nothing but C, G is nothing but H is H, and I remains I. So for this, from the set 1, 2, 3, 4, 5, now here there are 5 different variables. Those are A, B, C, H, and I. So for every variable, there are 5 chances, 5 possibilities. So similarly, B has 5 possibilities, C has 5, H has 5, and I also has 5. So it's nothing but 5 into 5 into 5 into 5 into 5. So number of P matrices with these entries are 5 power 5. This is the required answer to this question. In this question, matrix A is given, matrix B is given, and iota, we already know it's nothing but under root minus 1, and Q condition is given, and we need to find the value of this. So these are the typical questions which were asked usually in JEEs. So in these kind of questions, first we need to find out the A into A transpose. If this value becomes a unit, if this va if this A into A transpose becomes an unit matrix, then your problem is sorted. So let's check it out. That's 1 by root 5, 2 by root 5, minus 2 by root 5, and 1 by root 5. Multiply it, the transpose is nothing but 1 by root 5, 2 by root 5, minus 2 by root 5, 1 by root 5. 1 by 5 plus 4 by 5, that is 5 by 5, 1. Here it is 0, here 0, and here 1. So it's nothing but an identity matrix of order 2 cross 2. Now we need to find out A Q part 2021 A transpose, right? But before that, instead of 2021, let's take Q square. I'll show what's the trick over here, okay? Write A as it is. Q, there's a condition given. That's A transpose B A, and write square over here, and A transpose right as it is. Now square, just separate it. A transpose B A again into A transpose B A, and write A transpose. Now, if you can observe over here, A to A transpose is nothing but I. So now write A as it is, and inside becomes A transpose B as it is. A into A transpose is nothing but I. Again B as it is, A, and write A transpose as it is. Now any matrix multiplied with a unique matrix, it just be the same matrix. Now it left over part is A transpose B square into A transpose. Now you can observe over here, if it was Q square, then it's B square over here. So similarly, if it is Q part 2021, it becomes A into A transpose B power 2021 A into A transpose. So now we already know A into A transpose is nothing but I, and A into A transpose is nothing but I. So it becomes I into B part 2021 into I. It's nothing but B part 2021. So first let's calculate B square and find the pattern B square is nothing but 1, 0, iota 1, 1, 0, iota 1. It becomes 1, 0, iota plus iota, it becomes 2 iota and 1 over here. Let's find it for B cube, which is B square into B. Now it becomes 1, 0, 2 iota plus iota is nothing but 3 iota and 1 over here. So now P power 2021, it becomes 1, 0, 2021 iota 1, right? So option B is the required answer to this question.